Okay, we're going to do section 5.7, which is the binomial theorem. We're going to expand binomials using the Pascal's triangle, and we're going to use the binomial theorem. When we say expand, we're going to take equations like a plus b to the n, like a plus b to the third, and FOIL it out. Or a, like here's the FOILing out, we would have to multiply everything together to get this equation. Now, what happens is, a lot of times it takes a lot more work to get that equation. When it's to the second, it's not hard to do. The third, it's not even hard to do, but to the fourth, it gets more and more difficult. Now, you notice on here is a pattern. If you row 0 is a plus b to the 0 is just 1. Row 1, a plus b is a plus b, 1 and 1. 2, a plus b squared is a squared plus 2 plus 1. 3, and so on. Notice the pattern here. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So we work it out and as we go. The coefficients are the column matches of Pascal's triangle. Now Pascal was a French mathematician. His triangular array of numbers in which the first and last number in each row is a 1. Each of the numbers in the row is the sum of the two numbers above it. For example, we generate the fifth row using the sums of the equivalent in the row above it. So notice here, you got 1. Outside's always 1. Outside's 1. We take these two numbers to get the 2. Outside's 1. 1 plus 2 is 3. 2 plus 1 is 3. Outside's 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Outside's a 1. 1 plus 4 is 5. 10, 10, 5. Always the two numbers above it. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then the outside two rows stay 1. Now the first row of Pascal's triangle is considered row 0, row 1, row 2, row 3, row 4. So this is row 5. This is like to anything to the fifth power as we go. Now, what was the expansion of a plus b using Pascal's triangle? So, okay, a plus b to the sixth power. Let's go back and look at this row. And here's sixth power. We're going to use these numbers here. This is the sixth power. We're going to use 1, 6, 15, 20, 15, 6, and 1. But first, we have to get the exponents. And I'm going to get back to my problem here. So what we do is we're going to say, I always go like this. I go blank. Start with the first one, be a to the 6. Plus blank, go down with the first one, up with the second one. And now you notice I did not put b to the 0 in there. Plus blank, a to the 4th, b to the 2nd. Plus blank, a to the 3rd, b to the 3rd. Plus blank, a to the 2nd, b to the 4th. Plus blank, a to the 1st, b to the 5th, plus, and I'll go down here, a to the 0, b to the 6th. Now a to the 0 is 1, so we don't put that in there. Notice I put blanks in front of each one of these. Now let's look at the a's. We can start with the a's is 6. The first one's a blank car, so it'll be 6, 5, 4, 3, 2, 1, 0, and 0 we don't put in. And b would the same way, but the other way. B to the 0 we don't put in. 1, 2, 3, 4, 5, and 6. Now the numbers we put here, we're going to go back and look at our chart again. The 6th row, 1, 2, 3, 4, 5, 6, 7, 1, 6, 15, 20. So we're going to go back in here. Wrong way again. 1, 6, 15, 20, 15, 6, and 1. And this would be our answer. 1a to the 6th, 6a to the 5th, b to the 1st, and so down the line here. If we foiled this whole thing out, this is what we would get. And it's a lot easier doing it this way than it is to try to foil all out. A lot of times when we foil stuff out, we make mistakes as we go. For the binomial theorem here, it says a, b, n, p0, a to the n. Don't get caught up on this. This is now that we just talked about. This is what we just talked about in mathematical terms. Now, I'm not too concerned right now about this, but what I want you to do is look at this one. Now, first of all, when we do a problem like this, we're going to have to work it out a little bit harder here. This is going to be, and I'm going to think about this but I'm going to rewrite this as 3x plus a negative 2 to the 5th power. This is my A, this is my B. Now, if I think about to the 5th power, I'm going to do this in 2 steps. I'm going to have blank A to the 5th, B to the 0, plus blank A to the 4th, B to the 1st, plus blank A to the 3rd, B to the 2nd, plus blank A to the 2nd, B to the 3rd, plus blank A to the 1st, B to the 4th, plus blank no A and B to the 5th. So that's what it would look like, but now A and B are not A and B here. A is 3x and B is this, okay? So I'm going to go back and put that in there. So this is going to be A, which is 3x to the 5th, plus blank A, 3x to the 4th, and a negative 2, plus blank 3x to the 3rd, negative 2 squared, plus blank 3x squared, negative 2 cubed, plus 3x to the 1st, negative 2 to the 4th, plus, I'm going to go down a row here, negative 2 to the 5th. So we got a few things to work out here, and we can put our numbers in here too. So this is the 5th row. Let's go back to our column. 5th row is going to be 1, 5, 10, 10, 5, 1. So on here we're going to have a 1, 5, 10, 10, 5, 1. Now what we need to do is we need to work these out here. So that's going to take a work. First of all, 3 to the 5th. 3 times 3 is 9, 81, 243, and then get x to the 5th. So and times 1 is 243, so it'll be 243 x to the 5th plus. Now if we look at this out, 3 to the 4th is 81 times 5 is 405 times a negative 2 is a negative 810, and we would have x to the 4th. So we're just multiplying and doing the exponents here. Plus now 3 cubed is 27 times negative 2 squared is 4. It's 27 times 4 is 108 times 10 is 1080. X to the 3rd plus, now let's see what we got here. 9 negative 2 cubed is negative 8, so that's a negative 72 times 10 is a negative 720 x squared plus negative 2 to the 4th is 16 times 3 is 48. 48 times 5 is 240, I believe. 240, and there's an x there, right there. And then plus, and then negative 2 is a negative 32. And so, foiling this out, when we work this whole thing out, 3x minus 2 to the 5th, working this all out, we would get this answer as our problem as we work it out. So this is the button. It looks a little messy as you're writing it out, but once you get the pattern down, it's not too bad. And you want to get the pattern down because you don't want to foil it out. Can you imagine foiling this out and getting these numbers? There's a very good chance you're going to make a mistake somewhere. So, this is the one I want you to do for tomorrow. I want you to look at this one, set it up, and let me see all your steps to it. Don't just do it on the calculator. I want to see all your steps, kind of like I just set up this one. Do the A's first, then put the numbers, then simplify. I want to see that on this equation. Thank you.